Hello friends, welcome back to the lab. So we have started with your two labs. We have finished the two labs, and in the first introductory lab, we covered how to use the Xilinx software. How should you write the code using your Verilog style? Covered. So moving ahead, what we'll be doing now is we'll try to touch upon the next thing, which is, and after that in the second, yeah, after that in the second lab, we learned how to write a test bench, how a test bench could be written, and how it could be used to see the waveforms. All those things have been covered in the previous lab, right? So I hope so. You have downloaded the Xilinx software and you have started executing the codes, the two codes which you already learned in the two sessions. So moving ahead with the next session here today. So today what we'll try to do is we'll start with your experiment. So today we'll be starting with your experiment, the first experiment. So the first experiment statement goes something like this. So here what we'll be doing is you can just I'll just read out the statement. Write the Verilog program for the following combinational design along with test bench to verify the design. In that, the first one is 2:4 decoder realization using NAND gates only. And in the bracket, they are written structural model. So this is how your syllabus has been given. So if you try to understand this statement, what they have told us here is we should write a Verilog code. The first point is they have told us to write a Verilog code. The next point is we should verify the Verilog code by writing the test bench. So that's why the test bench was covered in the previous lab. That means we'll not be using directly the simulation force method, what we had done in the first session. We would be doing the test bench method, which we have done in the second session. Okay. So we'll be writing a Verilog code, then we'll be writing a test bench to verify this program. Next. What program we need to write? We need to write a 2:4 decoder, but what condition he has given here now? This 2:4 decoder has to be realized using only NAND gates. So this is very important, friends. 2:4 decoder can be realized using n number of methods. You can directly write a truth table and write the program, no issues. But how they are given in the syllabus, they are told you to do it using NAND gates only. That means using this method, we have to do the realization of the 2:4 decoder. So this is very important, friends. We need to do with what method they have specified. If we don't follow that method, the marks will not be awarded. Next thing. Next very important thing is he has used very specifically that you should use structural model only. You cannot use any other model like data flow, behavioral, and so on. The only style you need to use to write the code is structural model. So this is very important. So few things we have to keep in mind here. The first thing is while creating the project, you need to create a project which consists of Verilog program. That is the first thing. Next very important thing is when you'll be writing the code, you should write the code using structural model, and your basic, whatever the diagram, whatever the logic you will be using your AND gates. So I hope this is clear. And I also hope your structural model and your structural model has been covered in the theory class. That is HDL theory class. It has been already covered. I will assume that. Next thing is how to do a 2:4 decoder using NAND gates. This you might have already studied in your third sem, right? So while studying your digital electronics, you might have already studied this 2:4 decoder. So if you don't remember, please go back, have a recap. I'll be just touching upon how the decoder will look and how the diagram will look, but I'll not be explaining in detail. If you want a detailed explanation of the theory things, you need to go back to your that is digital electronics, how to draw a 2:4 decoder using only NAND gates. Okay, I'll show you the diagram, no doubt, but the logic, the detailed logic, if you want to understand, you should remember your D theory, or if you have forgotten, you should go back and should have a glimpse of it. Okay. Now, Coming to 2 is to 4 decoder, your 2 is to 4 decoder will look something like this. You can see here. So as the name itself is telling you, it has 2 inputs and 4 outputs, right? So A0 and A1 are my 2 inputs, D0, D1, D2 and D3 are my 4 outputs. Okay, so what we are doing now, we are decoding 2 inputs into 4 outputs. That's why it is called as a decoder. Next thing. So this is how your 2 is to 4 decoder will look using only NAND gates. If you can observe here, here I have my 2 inputs A0 and A1. Here I have my 4 outputs, which is D0, D1, D2 and D3. Friends, this is not a complicated design. You can easily go through it once you know the logic of 2 is to 4 decoder. So to give you a small hint, you should know the truth table of 2 is to 4 decoder. Using the truth table, you can get the expressions. Once you get the expressions, you can reduce it to only NAND gates. That's all, very easy. So if you know the truth, you know the decoder already right now, right? You can easily write a truth table. So once you write the truth table, from the truth table, you can get the expressions. From the expressions, you can reduce it to only NAND gate expressions. So this is my method. If you have your any other methods, no problem. We are interested in our labs only about the symbol. So this is my symbol and the logic diagram. So when you come for exam, we would just check what is the symbol you are written and what is the logic diagram you are drawn. Is the logic diagram correct? Because the whole program will be written by seeing the logic diagram. Okay, friends. So this is how the logic diagram will look. So I will go to your Xilinx. So this is your Xilinx. I have already written the code. Okay. So how do you write the code, friends? What is the method he has told us to write the code? The code must be written using only structural diagram. The code must be written using only structural diagram. So that's what we'll see now. I'll just try to merge both the windows so that you can easily see it. The main important thing is you can write the code only when you know the logic diagram. So that's why I've kept the logic diagram on the side here. I hope so it is visible. I'll just try to zoom the font. Yeah. Okay. So I hope so it's visible now. And the logic diagram as well. So friends, if you can observe here, yeah, if you can observe here, the first thing here in our program is, you can see here, the name of the module is what now? It is decoder 2 is to 4. It is decoder 2 is to 4. And how you are writing this whole code? Using structural description. Remember that we are writing this using a structural description, right? And inside the brackets, what do we write? The same method. The method remains the same. We will be writing all our inputs and outputs. So written all our inputs and outputs. So D0, D1, D2 and D3. Up till here, these are my outputs. A0 and A1. These are my inputs. Okay, friends. So this is one thing. At the output end, what we will be doing? At the output end, you will be writing all your outputs. So my outputs are what now? D0, D1, D2 and D3. So just cross verify them with the diagram which we have here, that is logic diagram. So you can cross verify. The outputs here are what now? D0, D1, D2 and D3. Yes. Similarly, here my outputs are what now? D0, D1, D2 and D3. Okay. Yeah. Fine. So now it's visible. Yeah. And what are my inputs? Inputs are nothing but A0 and A1. So similarly, here my inputs are what now? A0 and A1. So the first two lines are clear. Going ahead, next very important line is this wire. So I hope you have heard about this wire. To give you a small glimpse, wires are nothing but these are used to denote your intermediate signals. That is, we have two types of signals now. One is input and another one is output. Apart from that, we will be also having some intermediate signals which would arise from the intermediate devices. Like say for example, this first AND gate. So the output of the first AND gate is what now here? W1. Next, the X3 AND gate. So the output of the X3 AND gate is what now? W3. So these things, that is W1, W2, W3, 4, 5 and 6. These are nothing but our wires. Why these are wires? Because these are arising in the middle. These are intermediate signals. So basically we have three types of signals now. One is your inputs. The other one is outputs, which you have seen here, D0, D1, D2 and D3. The third thing is your intermediate signals, which are nothing but which are generated from the intermediate devices or intermediate gates. Here from X1 you are generating W1, X2 you are generating W2, and so on. So all these things also have to be taken into consideration if you want to write a code. That's why those are written in the form of the wire. So these are nothing but W1, W2, W3, 4, 5, and 6. So you can observe we have noted down all the wires. We have noted down all the wires. Okay, friends. Now, moving ahead, the first NAND gate. So what is my first NAND gate, friends? So how do you instantiate a NAND gate now? It is nothing but using the keyword NAND. So you will be using a keyword NAND. NAND. What is my NAND gate now? It is X1, the first one, X1. What is the output of X1? Output of X1 is what now? W1. So W1, comma. What is the input here? Input is A0. Please follow the cursor. Input here is what now? A0. So therefore here what we have written now? A0. So I hope so it is clear. I'll just repeat once again. The first NAND gate in the diagram you can observe here, it is X1. The output of X1 is what now? Your W1, right? So first we have written the output. The syntax says something like first we need to write the output, next we'll be writing the input. So you can see here, first we have written the output, then we have written the input. What is the input here, friends? It is A0. Similarly, for the next NAND gate, X2. What is the output? W2. What is the input? A1. So W2, comma A1. Next, we'll move ahead with the next NAND gate, which is X3. So if you can observe here in X3, what are my outputs? Output we have only one, which is W3. So you can see here, we have written here W3. What are my inputs? W1. The other input is what? It is tracing back to W2. So that's why W1 and W2. In this fashion, you will be writing for all the NAND gates. So to give you a glimpse, let's check for X5. This is my X5 here, right? So X5, what is the output of X5? It is W5. And what are the inputs? It is W1, this here, and the other one is, here you have A1. So let us check now in the code. For X5, this is my X5 here. What is the output? W5. You can observe here W5. What is the input? W1. The other input is A1. So you can see here X5, comma W1, comma W1, comma A1. So in this fashion, you will be writing for all the NAND gates, whichever we have. Finally, we come for the output NAND gates. So last NAND gate I'll just show you, which is X10. Okay, so this is my X10. So what is the output of this NAND gate? It is D3. What is the input? It is W6. You can observe here, it is D3 and W6 two times. Why two times? Because it has been shorted and the NAND gate has two inputs. Even though it is shorted, the NAND gate has two inputs. So therefore we have to repeat it. You can observe here W6 two times, W5 two times, W4 and W3. The reason behind this is very simple, because these two inputs have been shorted and has been given to only one output. That is the output of the X5 gate right now, where my cursor is placed. So this is how you will be writing your decoder circuit using structural description, first condition. The second condition is using only NAND gates. You can observe here we have used only NAND gates. Okay, friends. So I hope so this code is clear. If you have any doubts in this code, you can just WhatsApp me and you can clear your doubts. Okay. So this portion is done now. This portion is done. The next portion is we should write the test bench. We should write the test bench. Okay. So before writing the test bench, if you want, you can just execute and check whether my code is correct or not. Click on this dec.v, and then say check syntax. Okay. So the check syntax has been done. Fine. That means the syntax is correct. You can just check here in the console window. Next, we'll be writing the test bench. So this is your test bench, friends. I hope so it is visible. So writing a test bench, you have already learned in your previous video, that is previous session. What I would suggest is just go through this program, the whole program, that is Decoder, what we have written, and try to write the test bench on your own. Try to write the test bench on your own without looking into the rest of the video. So once you have written the test bench on your own, you can just come back, pause, and just check what is the test bench. Okay. So we'll see how the test bench will look. I hope so. We'll try this exercise, writing the test bench on your own. It's very simple, friends. Just you need to change the inputs and outputs what you had written in the previous code. That's all. Okay. So yeah, we'll check the test bench now. Yeah. So again, a test bench is written with the name module, right? We'll start with the keyword module. And usually we give the name stimulus. It is user dependent. You can give any name. Next, what is the next very important thing? We need to define your inputs and outputs. How do you define the inputs? Using the keywords register, REG. So using REG, we'll define the inputs, which are A0 and A1. And how do you define the outputs? It is WIRE, that is wire. Using wire, you will be defining your outputs. So my outputs are what now? D0, D1, D2, and D3. So I hope these two lines are clear. This we have already done in the previous session as well. Okay. Next thing, we should write the module wherein we want to map these inputs and outputs. So our module is what now? The name of my module is what? Decoder 2_4. So the same name has to be written here also. Decoder 2_4. Next, we'll be giving some instance name. Any name you can use here, any user defined name, but make sure about this module name. The module name which you have written here must be same as the module name which we have used here. Okay. Next thing. So we'll go here. Then you have written all the inputs and outputs which are there in this decoder 2_4. We'll be writing all the inputs and outputs using the instance. Next very important thing is what now? We will be giving the values. Okay. So the values we will be giving is your various input values and output values. So we have to give the various inputs and output values. So A0 is equal to 0, A1 is equal to 0. Then after the delay of 10 seconds, we will be giving 0 and 1. So A0 is equal to 0 and A1 is equal to 1. After again 10 seconds, that is here we have used 10 nanoseconds. So we'll be giving A0 is equal to 1 and A1 is equal to 0. And finally, A0 is equal to 1 and A1 is equal to 1. So after that, we'll be taking a delay of 50 nanoseconds and we'll be finished. So end. So this initial is end now. Whatever the initial you have started here at the beginning here, this is finishing here. So here we have written all the inputs. Fine. So we are given the inputs. Next thing is we should assign the outputs. So again, we'll be writing this in another initial. So if I want to see the output, the keyword we will be using is $monitor. So we'll be using a keyword $monitor. Next, what is this percentage B, friends? I hope you remember this was explained in the previous lab. B stands for here what now? Binary. That means the values which are written here, 0, 0, 0, 1, whatever are written here, these should be considered as binary values. So A0, A1, all these are, even the outputs, how we are considering the outputs, even those has to be considered as binary values. Okay. Next, we will be defining what values I have to display. So the displayed values are what now? Your inputs and outputs. That is A0, A1 and D0, D1 and D2 and D3. Yes. Finally, finish this end, whatever written here, you are written here, finish this end and end module. End module is to end this module stimulus. Okay. So once you write this program, you will be getting the head program is your stimulus. The head program is your stimulus. So first thing is what now? So it would look something like this. You press the plus sign, click on it, then you do the check syntax. You have a check syntax here. Just run it. So if there are any errors, I hope you remember where the errors would be showing. It will be shown in the console window. So check your console window. You can see here the check syntax has been completed successfully. So once this is done, you need to press this simulation. After pressing the simulation, you select the stimulus. You do this behavioral check syntax. Do the behavioral check syntax. Then you simulate the behavioral model. So once you simulate the behavioral model, we'll be getting the output in the form of the waveforms. So I'll simulate this. Okay, it is getting simulated. Yeah. So it is simulated. Next, you go to this default.waveform file. Go to this file. You can see all the outputs here, but all the outputs are not visible right now. So I hope you remember what should be done. You should press this button which is fit to screen, okay. Yeah, we have fitted it to screen. You can check the various values now. Just drag this yellow cursor or click on the wave where you want to see the values. So inputs are what now? 0, 0. So therefore D0 is highlighted. Next 0, 1. So therefore D2. 1, 0. Then D1. Finally 1, 1. Then D3. So you can observe the same values here as well in the console window. A0 and A1 are 0, 1. So therefore, which one is highlighted? D2. So just check that. Yeah, A0 and A1. So which one is highlighted? D2. Right? Next. Check for all ones. A0 is 1. A1 is 1. Right? A0 and A1 both are 1. Then which one is high? D3 is high. So A0 and A1 both are high. So which one is high? D3 is high. So I hope you have checked all the combinations of your decoder. Thereby, you can say that it is done. So this is how you will be writing your decoder using only structural description and using only NAND gates. Remember this combination. Don't use your own logic. Like say for example, you can write the same code using your behavioral description, no problem. But the syllabus is asking us to write it using only structural description. This is one thing. Next thing is we need to write this test bench. Because without writing the test bench, we cannot execute, because the method has been told to write the test bench, or else you can directly execute by using your force method. You already know the force method. Yes, using that method you can execute. No issues. Okay. So here you know already how to do the force method. Just right click here, say force clock, and you'll be getting the force options. We'll be getting the force options. Right? So this is not accepted. We need to write the test. How the whole thing is executed, how the whole execution has been done for the decoder. Please try this at home, because once you come back, it will be very difficult for you to try all the codes in the lab itself. Just try to download the software. Go into Xilinx website. Try to Google it out. Put Xilinx. If a free version of higher series is not available, you can download some lower series. No issues. The functionalities will remain the same. No compulsion that you should download 13 version itself. You can download some lower version and try practicing. Okay. So thank you for watching, friends. If you have any doubts in the execution part, in the Xilinx part, you can always contact us. We'll try to help you out how to execute the codes, how to understand